Welcome back after lunch. We are ready for the second part of this workshop, which is more of a panel discussion. We have many topics to discuss, but we agreed that Professor Will Recker will lead with the first question. We welcome actually comments and questions from the audience. And with no more delay, Will, you have the floor.
Yes, let me first of all say, I'm going to speak as a transportation researcher and one who is particularly happy to be immersed in what seems to be a bunch of geographers, since I've spent the last maybe 30 years of my life trying to operationalize time-space geography as defined by Hagerstown and Perez. But this morning's lectures, presentations, really raised in my mind some really interesting questions and ideas and concerns. They were all wonderful from my perspective because they sort of touched on ways in which transportation behavioral researchers could interact with the spatial plane and spatial information in terms of not only understanding things, understanding travel behavior or activity-based behavior, but also how it's displayed in the urban landscape. But a couple things struck me. One, and I raised a little bit of this with a question to Hani earlier, and it is, for the past 40, 50 years or so, transportation researchers, behavioral researchers, have spent their lives looking at disaggregate choice models of very simple data, times and costs. The idea that people make travel decisions based on travel time and travel costs. And in looking at that, only at looking at a single trip, and that's what led to the idea of activity-based modeling, the idea that transportation is a derived demand. But the idea, as Hani was showing, was this, the idea that people make decisions, where they're going to go, when they're going to go, how they're going to go, in isolation of other factors, particularly some of the things that he mentioned, ideas about friendship. Other friends are going with you. There's a reason for going where you're going. It's not just to go to work. It's not knowing just your workplace. There's so much of what we need to understand about what are essentially non-mandatory trips that involve aspects of travel that go far beyond the, quote, typical measures of utility. And for the first time in the past few years, now we've all of a sudden, with the information explosion, with social media, we're able to measure certain things that we couldn't before. I think some of the modeling that we've done in travel behavior has been limited by the kind of survey information we've had. There was no way prior to Twitter and tweets and so on that we could ever really measure with a survey, even a diary, the idea of friendship, commonality between individuals or among individuals. So our models didn't include that. So that was the first thing, the idea that our behavioral models are not structurally defined in a way that easily interprets that or takes that effect into account. So that's the first thing, the idea that, well, how can we take advantage of this wealth of information, rich information, and relatively common information in our behavioral modeling? The other thing that struck me, maybe this is more to me pertinent, is that maybe the models that we have and the model paradigms are not the ones that we ought to be pursuing. Maybe we don't need to know the behavioral foundations of what people are doing. Maybe the data itself is it. Maybe the information in the data, I don't care if it's a black box. If I can predict certain patterns, if certain patterns happen over and over again, because we are creatures of habit, by and large, and if I'm looking at not just an individual, but how the aggregation of those individuals' behaviors lead to questions about activity participation and travel, then maybe all I need to know is how the cloud evolves. The idea, as Christoph had with displaying the pulse of a city. Now, if you take that pulse and you combine it with the actual movement that causes that pulse and the people that are doing it, you basically have an activity-based model. And maybe that's what I need. So I'm just throwing out the idea of two things. One, how do we, and should we, try to force fit, or maybe it does fit, the kind of information that has suddenly become available, the explosion of information, with the model paradigms that we've been using in travel behavior research? And secondly, should we even try? Maybe it's time to step away and give up and say, okay, I don't need to know that anymore. Google certainly seems to think that. And I'll just throw that out.
Who would like to?
We can get rid of HAP.
Absolutely. HAP that he's referring to is a model I built out of Hagerstrom's Prism that I've been milking for, like I said, 30 years. And the thing is, when I first developed that, it was really set out to say, okay, wait a minute. People are constrained by what they do. And there are prisms, accessibility prisms for which they can get things. And I threw it out as an operations research model just in the hope that other OR people, because I'm not an OR person, would take it and run with it and do something with it. Well, they didn't. But fortunately, I learned, this is just an aside, I learned something a long time ago that the easiest way to success is to surround yourself with people who are smarter than you. To wit, Mahdieh, for example. Yeah, we can get rid of HAP. We can certainly get rid of HAP.
Great.
So what happens when someone doesn't have a smartphone? I mean, in all this human behavior, because I saw most of the research that the people saw was like, hey, I check in, I have this, I check in, I do that. So I mean, I have a smartphone, I never check in. I'm sure most of us will never check in also. And so what is the alternative? Like have some sensors on the humans and then track them?
Maybe, or maybe from our standpoint, most of us who are dealing with California problems, it's cars. No matter what you do, it's cars. And whether we like it or not, just from a financial standpoint, the state is going to have smart license plates and we're going to be able to track everybody.
Yeah.
So maybe that's where the information comes from. And maybe that coupled then with good land use data.
Yes.
And not just land use, but the kind of sort of what that means, and how that interfaces with the kind of needs or desires that people have during the day. Maybe that's the way to go.
Yeah. I think I agree.
Actually, there aren't some cities like San Bernardino actually tracking, the city government tracking license plates as we speak?
I'm not sure they are, but I wouldn't surprise me. I know actually. I think in Portland they actually have a pilot project where they are actually tracking vehicles. You know, just because the state funds, the general fund comes from primarily from the gas tax, right? So in the gas tax, you start going to alternative fuel vehicles that don't visit the pump. You lose that tax revenue that ultimately gets into the general fund. So the state is going to move in that direction, even if we don't.
Oh, absolutely. But for instance, Rand Corporation about 2 years ago produced a relatively interesting report on, what are the options for California for tracking mileage for cars, and I think Oregon might go the very active way, whereas we might go the passive way, where we're having an odometer readout every time we're at the pump, and we have to pay a tax based upon our odometer change.
Some insurance companies, they have this mileage tracking.
Yes.
So if you get it, you're just like, so they can, I'm sure they have lots of data there.
All right.
They figure it out too.
Let's go back to Will's fundamental question. Should we get rid of all the travel surveys and just go for the model, or shall we and use the internet or the harvesting the internet, or should we do something different? And Hani raised his hands. He has a lot to say.
Well, no, I just wanted to actually add to the first part of the question in terms of dimensions that we're missing, and certainly the social network angle has been missing from previous models, but other things have been missing as well, which I think some of these new sources of data can help us address. One of which is experience. Okay? Most of our models are one-shot deals. They do not really reflect the whole accumulated experience that people have. And with the kind of traces that we're talking about, we really have the opportunity to have to observe experience and use that to help us explain future decisions. The other is information available to the decision maker. What is the and as and you have criticized in the past. Well, many of our models assume perfect information that users know about all of the available alternatives and so on. Yet this is probably the single most important dimension that marketing professionals target. They play on the information that is available to you, and part of capturing the social influence is also capturing an important source of information that people have. And this is, in a sense, the more, quote, friends you have that you're interacting with, the more likely it is that the quality of the information that you have and also the scope of the information that you have is going to be richer. Similarly, with more experience comes information. So all of these elements, I think, tie together, and I think the opportunity really increases here to address a lot of the limitations that our models have had. Now, with the opportunity to have better models, what the key element that's missing is context. Is to know more about context and motivation and information, and that is information that only individuals can themselves reveal. Though it's not even clear that in the survey data that we have, the information that they reveal is directly relevant to the choices that we're trying to model. So that has never been perfect there, but there are certainly ways of obtaining that can, that are also more dynamic and location specific because of smartphones and similar technologies that one could be relying on. Now, with the opportunity of having better models, the question is then, do we even need the models at all now that we have all this data that's so good, it's going to let us have better models? And it seems that for many applications, the models in the form that we had conceived them are not necessary, or in fact, they become an impediment to the ability to predict better. If we're looking at supply-side decisions, for instance, particularly dynamic supply decisions, routing of vehicles, etc., then we just need transaction data, essentially, to be able to do that job and to do it well. On the other hand, there are some aspects where some level of processing on that transaction data that relies on the kind of models that we have developed in the past would be very useful. And I can, there's a freight context that I'm thinking of now. If you're a broker, essentially, that's matching capacity to shipments, then and you're quoting a price, the ability to have a model to predict the response of your shipper to the price that you provide is going to be extremely helpful to you in that context. So there are, but again, the type of model that you have is very, in my mind, needs to be driven by the operational implication that you have. And so the very complex and sophisticated activity-based models, essentially they're like, they're a huge hammer that you don't need for many kinds of nails, essentially, many kinds of applications that you're working with. But to go back to the typical sort of policy context and transportation planning, it's really never the model itself, but it's the information that the model contains about user preferences and about trade-offs, and whether the model frameworks that we've had are the best way to capture that information for those applications is certainly open for question. The decision makers don't seem to think that the models have much value. So I totally can concur that a sort of a revision of the need for models and the types of models for different applications in transportation is called for.
Thank you. I also have a comment on this. Because the internet harvesting is new, we tend to believe that is better than what we already have in terms of data. And very often we sort of forget to use the old rules of verifying, validating, building redundancies. And I have two examples actually where I have seen this. One is from China, based on smartphone traces. Somebody collected data for 14 different cities for entire weeks, and then showed on a map all these phones being active in different places of these different cities. For secrecy reasons, they could not tell you which city it is, but if you overlap the map to a city, you can tell. And one specific city, for 7 days, all 7 days of the week, had the same density of calls from the same major area, which happened to be a park. And this park is surrounded by, a natural park, not a cemetery, but a pleasant place. So I was on the dissertation committee, so I asked, how come the pattern that we see in the density is exactly the same for 7 days of the week? Don't these people change destinations depending on the day of the week, like in the West? And the answer is, no, Chinese work all the time. That's why you see all their calls around this park. And of course, I'm scratching my head. No, I've been in China. They don't do that. I've been on a Sunday there. So if you go back and you look at the data, it was a different set of people that they were going around that park on during the weekend than the people that they were working. You just get the same density per space of the number of calls. It's an illusion. So here's one case where if you don't have the additional information that people don't work on Sunday, you will not be able to say, oh, this is a completely different purpose by completely different people, and they just happen to be surrounding this park because in the park the reception was not that good, so you would lose the phone calls, right? That's one. The second one is actually, we're looking at some Twitter data with Adam Davis and Jay Lee, and I did not think about that, but they told me, oh, look, all these people are tweeting about something that happened in New York. But they are from California. So you look at this event and you analyze the text or you geotag them and you think that something horrible or very happy happened in one location, when in reality it happened all over the world, and the tweets are containing information about elsewhere, but they are geotagged here. So now you start to infer that something happened in Santa Barbara, but really it was happening on Fifth Avenue in New York City. So what does this tell me? We cannot live with one type of data when we try to understand what happens there. And we cannot estimate and create models that are relying only on one type of data. We need to start thinking about fusion. So this is where it comes to Will's question of, should we get rid of all our previous models? And my answer is yes. But the ones that we're going to build have to be much smarter than take into account the qualities of the different sources of information. And that is extremely hard because some of us got trained in econometrics. We will be thinking econometrics. Others are trained in data mining, which is a neighboring type of specialty, but different. And then they will be thinking about data mining. And some people will think about game theory, and again, they will be thinking about solving the problem. So some interdisciplinarity, some whatever we want to call it, it needs to happen here to retrain ourselves, to rethink in different ways. And that's what we're missing right now. But we're building it.
But we're lucky because all those other disciplines like computer science, data mining, and they love data. And is there any more data than traffic data out there?
Kyriakos told me, do you have any data for me to do a model? As soon as
I was just going to say that you're right, but a couple of the examples you gave were issues that we should be able to eventually be able to detect by patterns and anomalies and so forth. That is, it we'll be able to identify those people that are going to the park in China on Saturday and Sunday versus the others. Once we have a way of handling the richness and maybe embellishing the data that we're collecting, from cyberspace, if you will. I agree with Will that that in the long run we will be discarding most of what we've done because we're going to have to, just like moving more towards micro scale behavior and multiple trips and daily patterns and various other things. In terms of trying to make sense of transportation demand, we're going to even be moving beyond that in a way to a point. Maybe we don't, I hate to say Will's black box, but perhaps maybe we will be trying to understand this data long after it's become useful as a black box.
Yeah. Yeah.
Well, I guess the optimistic viewpoint is that from the talks that we had this morning and from the people here is that we have the interest of the various disparate areas that are poised and able to perhaps reinvent the way in which we look at travel behavior and how it impacts cities or other non-urban areas, but it's mostly cities.
We tend to talk, but we don't let the younger generation tell us.
Can't sit back.
Can I add on something?
Yes, of course.
Like if you look at transportation as a kind of market, like if you want to look at to see that who are trying to target people and address people's needs, in that case I believe that we need econometrics models. Like for example, if you want to develop some justice, environmental equity or justice problems or those things, and you want to target some minority populations, different ethnicities, in those cases we need to go and study their disaggregate travel behavior. These models are perfect, like Twitter, Foursquare data are amazing, but first they have bias. Not everyone uses them. And also the time of the day and the events I'm going to use Foursquare or use my Facebook checking all the times that I'm spending time with my friends. So it's not the time that I'm going to the work or I'm doing other activities. So that's one part, so it makes these data not that much probably reliable. Definitely we need other sources of data to use them, collect them, and also mine them and understand them. And the other fact, as we talked, if you want to have some policy which targets special needs of the people, like some special groups of the people, in that case, or for example, bike riders. In a city you want to have bike riders. We need to know that who is going to be most likely use bike. In that case, we need to know that what are these people, where they are coming from, where is their home location, rather than having only spatial temporal distribution of the patterns in the city. It can give us the idea, but as long as we don't know where these people are living, where these people are coming from, most of decision makings that policies that we are trying to address probably are not going to be successful. Or one other application would be like resource allocation, or in terms of like extreme events. It's important to know that where these people, you want to accommodate them, where these people are living, where are they going, what's their daily routines. Definitely, unless you use GPS data, unless we use very special like mobile apps like Moves, which tracks you exactly where you are going, who you are. Otherwise, having this aggregated level data, which is amazingly good, but they should be used as a kind of side models, it's my opinion. We need still that optimization models, which is based on network-based models, because it shows the infrastructure, the dependency on infrastructures and the people's behavior. And also we need to understand who these people are, what are their needs are. So that's my...
The last thing that I would suggest is to get rid of optimization.
Well,
if you know me, not yet.
It depends, yeah.
But on the
For
other
the
hand,
infrastructure case, definitely we need some optimization.
but on the other hand, when we're trying to understand people and what they're doing and so forth, the issue is, in the short run, we're not going to be doing much different than we are right now.
Definitely. Yeah.
But in the long run, we're going to transition. There's going to be a lot of interesting twists and turns in this development.
Yes.
And eventually, the kind of data that we're getting will become extremely useful for modeling not just the demands for individuals, but also the trips that are made by service vehicles and other people, and probably even doing a better job in terms of modes.
Exactly,
So-
but we need to be very careful when we are using those data also, because the biasness and also there are a lot of things that definitely the transportation person needs to know those things and travel them. And so I know that it's so scary, like everyone thinks that computer science people are way advanced than us and they're going to be way forward, but at least we need some transportation mind behind it to be able to analyze and to do some forecasting over there. But definitely I agree, yeah, the gap is closing and we need to use them. We need to be able to understand and talk in the same language so we can close this gap between us, yeah.
So now I'm going to call on Kyriakos because one of the data collection or information that we did not see this morning, but in transportation we do is experiments in laboratories, and those can be experiments in an actual physical laboratory, like the halosphere you were mentioning. The halosphere, for those of you that don't know, it's a big sphere that you get in, and you have a 3D representation of an environment. So you can.
Have it in Santa Barbara?
Yeah,
Can
over
we
here.
visit it later?
Yeah.
Okay.
Kyriakos offered to get. Yeah. And actually, one of the visits I did there was walking through the brain of a human being.
And,
And asking, yeah.
Wear
Okay.
glasses and you can see it. Like also
Yeah.
they have a 3D picture and 3D sound. Yeah.
So this is to the extreme. We were having laboratories, the Pullman laboratory, which is a computer screen with a chair, and you create these experiments. One of them is called stated choice or stated preference type of studies, and those can allow you to go in depth into the decision making, limited by other factors, but you can create also a game. You can have the two persons competing for something. You can have multiple persons competing for something. The internet opens up, or the webs and the social network technology opens up the possibility to set up games that are played by different people in different places, and then you can track how they adjust their strategy based on the opportunities. You can do all kinds of more interesting type of experimentations. And if you are afraid that it's a self-selected sample, you can also repeat it in a laboratory. It's okay. So how?
So we have.
Do you want to give us an overview of what
So
you're doing?
we have done similar experiments with humans for our Nuri project. So we designed some optimization tools for cybersecurity to forecast attacks in different services, in a computer, let's say anywhere you can imagine.
Yeah.
And so we had just people throwing that there and try to work with the optimization tool we built. And based on that, we separate the people with different way they perceive attack, the way they defend, etc., etc., etc. And there were three kind of people. So I call them with maybe it's not a good idea to call them that way. So I call them the really smart people, the mediocre people, and the last one is not that good one. It's the dumb people. That was an insight. That was an insight.
Yeah,
but
that's
I
just
wanted
a model, not
that's the
in
model.
reality.
Yeah. I didn't really call them like that. Yeah, I know. It's okay. And so we had about 40 people. So everybody brought their friends. So maybe some of our friends aren't that smart. So that's what I thought. Or maybe it was our fault. So now I go that we are dumb. We're not that smart because we didn't really explain them the optimization tool. But we just throw them there. We just give them a small tutorial, like about 10 minutes, and then we expected that they know. So we discovered that the people that they were more into engineering, computer science, they were better than the people that they are in philosophy or biology.
Or biology.
Yeah. Because, I mean, they are better with computers, the people in engineering, and also in computer science, in everything you can imagine. I'm sure they're better than in computers in people with respect to philosophy. Philosophers are better in reading, people in writing essays and stuff. So everybody has their own talent. And then we tried another experiment. So in the people that they didn't do that good, we randomized some stuff in their tool, and then we gave them a tutorial, and then they did perfect. So I think it's always how to train them, and then what models of the humans you are collecting from. That's what I'm saying, that people checking in, people checking out, people doing that, people doing the other thing. It all depends, I mean, what's the level and the background of every person in this experiment. And so I don't know, these human experiments were really tricky. So we saw them to the army people that they fund us, and they wanted to test it in their people, but they never told us what was the result.
So are you saying that the gold standard is always the real life experiment?
Yeah,
Is that the conclusion?
Yeah.
So are you suggesting to the transportation people that we actually go out there and give them a hybrid electric car for a year and then come back and see what they do? Is that because that's what you're implying?
Yeah, yeah. So I collaborated with a guy from USC. It's called Petros Ioannou.
Mm-hmm.
So he's also a control guy like me.
Yeah.
He does adaptive control. So Audi is working with him. So they gave him an A8 Audi. So he let his student drive around, drive to San Francisco, anywhere. And they were collecting human driver behavior. And so again, this answer. So I think it has to be more specific.
If you switch the A8 with the BMW 650, I will participate.
It's a good car, though. It was a good car.
Could it be that the experiments that you have designed reflect your own sort of background and biases, and therefore they're better played by people with similar background?
Exactly. I agree with you again. I agree. That's what I said. Different level, different all that. So it's always like that. I mean, if we give, let's say, some experiments to some people from transportation, it's about transportation, the experiment, then I'm sure they will do better than some people from biology or philosophy. Or
the experiment that Hani will design actually will reflect two things. Will reflect the engineering, but also the because the background, his background is engineering, but it's going to reflect also other cultural traits that very often we don't know, even ourselves, and an overall conceptual framework about how the world works. And we see this in data collection. When you really scratch the surface how somebody designed to collect data, and you look at the questions they ask and the format and everything they do, you can tell what type of model, conceptual model they have in their minds. So I very much like Hani's comment, because you use the philosopher. The philosophers maybe would not need a computer. It would be a discussion like this around the table, or taking a walk.
No, you're absolutely right. You're absolutely right.
And we don't know how to do those things. And the real world is made of a combination of all these different people.
Exactly.
So here we are. Here's the dilemma. We are designing a world according to our norms and cultural traits and conceptual models. And then we say, why is my model not working right? Because it was only for you.
Yeah, and like most of our people that we work with vehicles and stuff, we always consider most of the times we have a driver. I mean, 30 years, I think the driver will not be there. I mean, it will be like a passenger. So they will be fully autonomous, and all these models, all this human behavior will most of the times will not be there.
Yep. Okay. So we don't have our two GI science person here. I had quite a bit of questions to ask them about the ontology, but that's okay. They escaped. We'll do it in our department.
In the faculty meetings.
Yeah. We did not have a chance to let our audience ask any questions. We need a. Thank you, Nate.
Thanks. I have a question about the data and this new tendency of the internet of kind of free data. I'm thinking of, we know that data is biased because it's not specific, or it's more specific for certain groups that use that, that kind of artifacts like smartphones. But I'm thinking if the data is almost for free and is biased, I want to make an analogy that maybe could be considered. Let's think in the oil. When we extract the oil, we have to refine the oil for getting certain products, but also are byproducts that we maybe are not interested at the beginning because we want only one. But later on, we find that byproducts are so valuable sometimes to give more value to the whole operation. And the question is, could that happen with this voluntary generated information?
So secondary use of data.
Yes, and
Not-
complementary,
yeah.
and maybe for other uses also. Or
Anybody wants to take this?
Well,
Go ahead. Oh, no, go ahead.
if I understood you correctly, you're talking about perhaps corporations and so forth having the chance to take advantage of the data that's being collected, like Google. Did I? What?
Now it's possible that almost anybody who has the ability to write a software can get that data.
Right.
Are APIs which are almost free? Or?
Yeah, so technically it could be a corporation that has added value by Google's phones and Android phones and so forth, or it could be even somebody surreptitiously taking data, because there are a lot of apps, I understand, that if you download on your phone, you are unwittingly giving your location data out, and so I think that it's a no-brainer to say that a lot of that data, if it becomes public in some form or another, whether it's kind of taken from you or so forth, that it's going to be used, and it's going to be used in some very innovative, productive ways, and I suspect in some very sort of abusive ways and within the context of trying to manipulate you.
Yeah, I mean, absolutely. That's exactly what a lot of us have been trying to do, in a sense, trying to find travel behavior and traffic patterns and data that other companies are collecting for their own purposes. And if anything, there's a lot more of that could be done once some of the privacy considerations, for example, are lifted. I mean, for the longest time, we've been wanting to use cell phone data, and today, while you could get some cell phone data with a lot of restrictions, we're nowhere near being able to fully take advantage of that. So, and I think that's the whole challenge with data and with big data in general, is how you can leverage data that you collected for one purpose to do a lot of other things, and that's what businesses are built on. If anything, we don't do enough of that as modelers and transportation planners. So yeah, absolutely, that's certainly the direction and the trend here.
I think that for the big corporation, it's not easy to share that data, right? I mean, Google, Facebook, et cetera, they don't really share because it's privacy concerns and stuff, right?
Yeah, I mean, in other areas, we've been working with companies that on the freight side that have and logistics side that have a lot of transaction data. And they're all looking for ways to mine that data and to extract value, both for operational purposes and for marketing purposes. And I'll give you an example there's a financial institution that handles a lot of the payment, that handles payment systems for shippers and logistics companies. Well, we've been working with them trying to use that data as a basis for benchmarking, so that because from that information, then other companies can benchmark their own what they call spend on transportation, but they could also benchmark it on operations, because part of that data contains when things were picked up, when they were delivered, and how much it costs, and so on. So I mean, it's an active and it's a major area of opportunity, I think, as well.
Yeah, I have something to add on this too. The transportation people, researchers especially, somehow we have developed a talent for cannibalizing data wherever we find them. The database that we use all the time is the US Census, at any form, from the micro data to aggregate data. Long form of the census, which in the United States used to be an inventory of the commuting time and that people did. Now it's called the American Community Survey, so it became like a normal survey, but we had a lot to do with its design and the use, because we need this for major planning. But also, the latest database that comes to us from Nokia, some of us call it the Nokia database, are smartphone traces that can tell you the amount of cars that are on the network and the travel time. And travel time is extremely important for us. So we're doing that in the same way that we did all these things in the past. Now we're moving into harvesting Twitter and Facebook and whatever database we can. So we go very, very, very fast. But sometimes in going very fast, we make mistakes, and then we come back and we fix them. So I'm not worried about the transportation professionals being able to do it. I'm more worried, and we are trying in California to institutionalize this and create what they are called archives and observatories. In fact, Jano that was here this morning is designing an observatory where we have a continuous funding that allows you to harvest the internet and then prepare the base database, the basic database with metadata that explain to you what you have for secondary uses that we do not know what they are. And it's very, very hard to go to an elected official and say, don't worry, give me money, I'm going to build this observatory, but I have no idea who's going to use it. Because they will say, oh, wait a second, why am I going to tell my constituents that I spent $3 million for you to build an infrastructure, but you have no idea what to do? So that's where we come in, exactly what you said as transportation, and say, we are going to predict volume and congestion and displays with this data. The public will gain this amount of money by eliminating congestion, decreasing CO2 emissions and things like that, so that we can build this infrastructure that allows us to do the secondary data manipulation and collection and manipulation. So that's for me. All right. Any other?
Actually, speaking of secondary uses, if I were to point to probably the single most important development in transportation planning in the past 15 years, I would say Google Maps.
Yeah.
I mean, that's so.
That's right.
Some questions for.
Oh, you have
for
a question?
Guys. Like for
We have
transportation.
to, yeah.
Like, what are the funding trends for transportation now? What do they want to fund? What are the hot topics to work on?
Secret.
Will.
Unfortunately, I think from my perspective, the hot topics are the problems that need to be solved tomorrow, as opposed to 10 years from now. It's in my experience that it's getting increasingly difficult to get funding to look at what you just mentioned, ideas or research that is high risk, basically. May pan out, may not have a defined objective or deliverable other than better understanding, or maybe lead to some discovery. So I think that's my perception of where things are going.
Any specific topics that the funding agency they're looking for? I mean, maybe for some people that they're studying their PhD, maybe they want to.
Greenhouse gas emissions in California to meet the SB 375 dictates, accidents, and congestion, of course. These are the
hot topics.
mainstays.
Yeah.
Yeah.
No.
Yeah, but they have been the hot topics for
Forever,
the
huh?
past 40 years.
Yeah, but as you mentioned, you know, the new the regulations relative to greenhouse gas emissions have enacted rules and regulations by ARB and so on that are geared towards developing urban forms that it's tied to land use. So it's good for this group in particular because it's, you know, geography, land use. Developing better ideas about how to mitigate congestion and greenhouse gases via changing land patterns. But that's immediate, and of course, if you look immediately, the goal is say, okay, well, how do we get people into the cities, living in high-rise apartments and taking transit? And how do you do that now in urban areas? Well, you raise parking prices. But if you look ahead 20 years, for sure there are going to be autonomous vehicles. That has all sorts of implications about shared use, but more importantly, it has implications that, okay, what is my choice? If I'm going to work in a city and I can either pay high parking, or I can have my autonomous vehicle drop me off and then drive around and wait for me. It's cheaper. And not only that, I would like my autonomous vehicle to be stuck in traffic because it lowers the energy use that it doesn't cost me. So we're not looking at those kinds of things. Again, it's a question of what is the forecast year you're looking at, and being able to better deal with uncertainty in terms of projections. I mean, if you think back 10, 20 years ago, who would have thought anything? If I would have come up to you and said, yeah, this is what's going to dominate the marketplace, you say, I'm crazy. Yet it has changed everything. What's going to happen in the next 20 years? Again, we can see autonomous vehicles. We can also see places like Google, Microsoft, Apple becoming car manufacturers. And what are those cars going to look like, and what are they going to do? And how are the people going to use them? No one, to my knowledge, there is no funding out there to look at those kinds of questions. I don't know. I might be.
No. Even Uber caught everybody by surprise.
Yeah. That's simple, right?
Yeah, that's very simple.
Yeah, very simple.
They
Some
had
people
no
out there
idea.
they have cars.
They had no idea.
We can give them some money to drive people around.
Power systems. These are the hot topics.
So let's take the. I saw two hands. Yeah, go ahead.
So I have two questions. Dr. Recker, is it working?
Yep.
You talked about replacing behavioral models with black boxes. So if we do that, yes, black boxes we have all huge sources of data, and we can have even better predictive powers using black boxes. But then another use of the models is that if you want to have a certain output, you have an idea which buttons you have to push to get that output, which is helpful to decision makers and policy makers. So what are we going to do about those aspects?
Oh, I mean, I'm not advocating that we go to
Yeah.
black boxes. I still want to have a
Okay.
job for a while anyway, or something interesting to do. The question is unknown. And again, the big pariah of black boxes has been that, well, okay, then you don't know, how can you use them for policy? Because you don't know you just know if you put this input, you get this output. But if you have enough of that, then you have enough use cases that you can say, okay, well, this happened over here, so it'll probably happen over here as well. I don't know. I'm probably the worst person to ask that because I don't do black boxes.
If you have a black box, then and you have input-output, then you can find a model by using system identification, and then you can find.
That would be a model again.
Yeah, but it will be an approximation of the model. So I mean, you won't have an exact model since you have input-output data. I mean, it's always you can approximate a model, and you can find even a group of them, and then see what's going on. I mean, I think that's what black box means, that you don't have the model, but you have a mapping from input to output, and then based on this mapping, then you can do some identification, and then you can find an approximation of the model.
Reverse engineering.
Maybe a
Emulator.
generalization is
Yeah.
what I meant by black boxes is that there may be models that that are explicit relative to what the data looks
Yes,
like,
yeah,
the
yeah.
structure of the data.
Yes, exactly, yeah.
And that's the model.
Yeah, yeah.
These data, this outcome has this structure relative to the input.
Yeah.
Okay.
I have another question. Thank you for your answer. So you talked about the fact that we have there are all these factors that play a role in a person's decision-making process. So you talked about whether using utility maximization objective functions is the right thing to do. But is it the question that maybe the question is that maybe we are not using the right terms in our utility in defining our utility functions. So is it that we are not maximizing utility, or is it that we are not using the right terms in our utility functions?
It may be two things, both in my mind. One, for sure, we're not using the right terms. The terms of times and costs, and maybe just time, explains an awful lot of the habitual trip to work, but that's terribly uninteresting. So we spent, in the early years of transportation behavioral research, we spent like 20, 25 years trying to explain why the 5% of people who take transit don't take car. Okay, and it doesn't really matter except to the transit agencies, I guess.
It's the constant. It's the constant in the model.
Yes, it's the constant. It's a constant. But the thing is that those models in maximizing utility, there's a nice concept. But we specified them in terms that we could measure. And the things that we're talking about now, about like the example of going somewhere using a car with 4 seats because I've got 3 friends to pick up, is very, very difficult to put into that kind of framework. The other thing, though, that I'm thinking, and particularly looking at the young audience out here, is that, I go back in the day. Folks like me maybe used to make decisions methodically by considering things. I don't know, it seems to me that today's generation, and maybe even yesterday's generation, I go back yesterday's generation, but today's generation are more inclined to discovery as opposed to deductive decisions. So, I mean, the first thing you do when you get a new game, no instructions don't come with it. You don't know what it does. Okay, so but when they did have instructions, you throw the instructions out. Just go and try it. And so that has implications about, okay, how do you choose a route to work? How do you choose if there are new options out there? Discovery. So I think this is a wonderful time to be a transportation researcher, because the problems are so interesting, and I think the real advances that we make are not going to necessarily be built on pecking away at the frontier, but maybe way out there just because of technology. Long-winded answer.
Hence, going back to the earlier question about funding and so forth, that's what makes it a bit of a concern to me, because we really need to be funding projects that are really on the frontier, that really move us, rather than pecking it away at little bits and pieces.
Yeah, so I kind of wanted to add on the whole data-driven kind of science and modeling. This new year, I don't know if you guys are aware, but Uber kind of had a big problem. I mean, they have all this data about their customers, where they are, what time they leave, their destinations, and there was reports that a lot of Uber drivers did not make a lot of money on New Year's. And it turns out that the week before they had advertised that, hey, rates are going to be high, make sure you plan for this. And it looks like their customers listened and planned other alternatives. And so they took taxis, which are capped. And so when you're
Lyft.
yeah,
Also
and
Lyft.
so yeah, Lyft. Yeah, and so when your business depends a lot on data, I mean, then you get situations like this. It's kind of like, how do you manage? And so, I mean, so I wonder, I mean, yeah, we can use data a lot, but don't we kind of also need these models to kind of figure out, okay, now how do we understand what happened, but also if we want to do something about it, how do we, go about? Because, I mean, some could argue, okay, well, we could put some cap on the price. You know, we can say Uber can only charge 3 times the normal fare, or do we just add more drivers? What do we do? And so how do we get that type of information from data? I mean, we could harvest all the data we want, but we don't know what's going to happen. And so models, I feel, are also needed for experimentation, for knowing, hey, what will happen if we do this? And so, yeah, and now with the autonomous vehicle example, I mean, yeah, shouldn't we just work a little harder to try to integrate these things into the models rather than just be like, well, it's too hard, and yeah, so.
Go ahead.
Just one comment, I guess, that ultimately the models encapsulate the knowledge that we have collectively about the field. So they're really not going anywhere, in the sense that as a field, we will continue to produce models, because ultimately that's how we create and encapsulate that knowledge from the data. The data then serves to build the models, serves to calibrate perhaps. But part of on the operational end of things, though, there is a lot more that one can do with types of models that we have not used in the past, largely because again the data and the context wasn't there, and so that opens up a lot of new opportunities for us. But the model building, I think, as a trade will remain essentially what we do.
That's right. Thank you. So, any closing remarks from our panelists? We had enough?
So
all right.
There is a lot of research that can be done by combining ideas from different fields, like math, computer science, engineering, geography, anything. I mean, and I think there's a lot of room. So people, they have to get together and collaborate, talk about different ideas. And because, I mean, some people from computer science, they have another perspective, they think another way. But I mean, people that they work in transportation, they think another way. So if they meet in the middle, they can have a good algorithm and a good result.
Thank you, Kyriakos. Now you just told us we're doing the right thing with this workshop. So first of all, I would like to thank our panelists for a wonderful panel and quite a bit of work that they put together. This was really good. I will work with the audio-visual, with the instructional service, and see how you can get a copy of your video to enjoy it. And we have also, as a token of appreciation, a very transportation-like gift for each of you that we'll give you. Oh, yeah. No. Here's the bag. So,
no, you can use that.
I know Hani wants it.
Forlornly, right?
Thank you. Will I pass it on?
No, you keep it.
It's
Christmas all over.
Thank you.
So this is the first installment for eventually getting a car out of UC.
Is it autonomous?
It's not.
Ooh, I like that.
Nice color. If you don't like it, we can exchange it. We have one more pink Cadillac.
So, Kostas, I got your BMW.
Yeah, me too.
You still have your BMW? All right, and with this concludes our workshop. Thank you very much again.